Hello, and welcome to the third AIS developer video. The subject today is remote control of an Android device, specifically transmitting finger touches from the client to the server. We're going to follow them all the way through. First of all, we're going to look at the developer documentation. If you look at my desktop, you will see the generated documentation. What we're looking at is index.html, which is a checked-in file. It's in the root of the Git system. So if you've got all of the code checked out, then if you look in the root, you see index.html and you start it. Inside this fairly simple file are links to all of the code documentation. What we've done is we've documented the code, so all of the public and protected functions and attributes have Javadoc style documentation, and similarly on Objective-C on Apple. We've used the appropriate tags, code tags, so that we automatically generate all of this documentation into HTML files. So all of the documentation that I will show you now is also available directly within the source code. If you are a developer and you have access to the development tools, that is AIS Studio, Android Studio for Android apps and Xcode on Macintosh or on VirtualBox for iOS apps, then you're probably better looking at the source code because it includes the same documentation. Let's look today at the apps used for remote access. You'll see them here. AIS 202C and AIS 202S are remote access client and remote access server. And if you click through there, it goes straight to the generated documentation. The main user interface class is full screen activity. Here it is. And all of the stuff that happens in the back end, because Android doesn't keep a process running unless you create a service, we put them all within the remote control client service. This means that our functions are immune from being switched out. This is the documentation for it. So you see here, for example, here are some of the constants. The remote server, user, port start, port end, all of these are parameters that we put in the code. If we go down further, we'll see the functions. So here we go, a boolean get console is running, finds out if our console is currently running. Kill PID, you can stop any process by PID. Of course, these functions are on the client, and some of them will only be fully powerful if you've got root access. So that's what the documentation looks like. Here, for example, start running. Create and deliver a start running command to the service. Effectively, it starts the service if it's not already running. And if we go back to the very top, we can then access the remote access server documentation. It has the remote control service running. So again, because we're remote controlling the device, it wouldn't be any good to simply have a user interface application, because as soon as we switched away from it, we'd lose control. So we have a service running in the background, and it has high-level access so that it can continue running and it can control anything. That's why the server needs root access, but the client, however, does not. Here is the class, remote control service. You'll see here's all of the usual constants, the IP address and port. Most of these are, of course, defaulted. And then here are the functions. So there are some utility functions such as ensure directory. That function is simply called with a string, and which is the name of the directory that you wish to create. And this will make sure that it's created despite changes in rights and access and all kinds of weird things. It seems to change with every version of Android. So that's a brief look at the developer documentation. The same documentation, of course, is also in the code. You can access it here, and these are links so that we have all of the documentation in one place. If you look at the documentation of Macintosh-based iOS apps, you'll see that it looks very different, but still linked. So here's Reality Invaders. I don't know if you noticed, but it's a different format. We're actually using Doxygen on the Macintosh for the Objective-C code, and then we're using JavaDoc on Linux and other platforms for the Android code. Let's have a look at the list of classes. These are all the different classes we have. So a simple one here would be the Invader ship. There's its inheritance diagram. And the Invader ship has a three-dimensional position, velocity, acceleration. This is quite straightforward. And then the constructor. And we can even look at the code directly here, document. But anyway, that's for a later video. So that's an overview of the code documentation. Now, what we're going to do now is to actually fire up the client and server and send some touches across. I hope you can see, you should be able to see an extra Android device beneath me. So I've got my usual developer one just below here, that's the server, and then temporarily we have another one. I think it should be this way, it is next to it anyway, showing the client, and the client does not have root access, but the server does. Let's start it up. So there's the server, AIS remote server, which we're going to be running on this development device. So I've touched the server on button and you can see it starting. You see the log from earlier tests. So it's starting. We're waiting for the two icons, the red ones, to go green to indicate that it's listening for VNC connections. We're using VNC protocol for the GUI remote control. And we're using SSH for the command line. We're using the protocols completely standard, but we are using all of the encryption and compression aspects, because if you don't compress it, then the amount of data is simply overwhelming, and an average Android device, so not the very powerful ones, but an average one, will get bogged down and will lose responsiveness. So we use compression for that reason, and we use encryption because obviously we want this to be secure. We could have used our own proprietary protocols, but we used standard ones for a number of reasons. One of them, in development, we can use standard VNC and SSH tools. You don't have to, this doesn't have to go Android to Android. You can go Android to any machine running SSH or VNC, and vice versa. Which is very useful for testing, because you can find out quickly if a problem is on the client or on the server. That's the server running. Now we're going to run the client on our second device. So if we refresh the list of servers running, there we go, you can see the toast there came up. So the most recently seen one is the one that we've just started. It's at the top of the list. Notice that the description is the same, Coderoom's Samsung Galaxy S6. If you want to change that description, you can do that on the server under Settings. You see there at the top, device name, and you can change the device name there. We won't do it at the moment because the app tries to come up with a sensible name based on whatever information it can find on the device. So if you put your name in or something else, then it might say your name's name of the device. But if it comes up as just as a number, or because it wasn't able to find a sensible human readable string, just change it to something you'll easily recognize. You can see some of them here. These are all the ones that we've been able to find. Liam's S7 Edge, Gifted Cloud Samsung S4, HTC One, Tab 2, a Samsung Note, looks like Note 4, and Xperia Z. So we've got a lot of different devices. They're not necessarily listening right now. That's the ones that we've last heard, because we go and find them when they're requested. So at the moment we're going to connect to the top one. Notice we've got two options. On the left, the command line for SSH, and on the right, GUI connection using VNC. We're going to do VNC at the moment. And there it is connected. You'll notice that the client screen is showing the server screen, and it also is showing its own status line above. So you can see two status lines there. Don't get them mixed up. And all we want to do now is to send a touch. So if you watch me now, you'll see me do a touch, and you'll notice that it generates multiple events because, of course, there's the down, possibly drag, and up. And there we go. On the left there, you can see it logged all those. It was several touch events. And in a minute, we're going to trace those through the code and see what happens to them through the client down to the C++ code, because, of course, the actual apps that are providing these protocols are written in C. We use, wherever possible, the standard code, especially for SSH. There are a large number of protocols, and if we use OpenSSH, then we're guaranteed to work with all other SSH clients and servers. On the client also, if we want to send any meta controls, then we click with two fingers simultaneously. So I'll do that now. I've just done it on the client, and you'll notice that the server becomes a window. We get the client title bar on the top, and we get a row of buttons at the bottom. These are so that we can send these commands to the server. And you can see there's back is the one on the left, then the circle is home, the square is multitask, which gives you a list of all of the apps running on the server. The next one is power. That will actually power the server off, so don't do that unless you really want to. And the last one is disconnect, which will disconnect the client from the server. Before I use any of those, I just want to point out, because we will be looking at this later, you'll notice that the log there, inject touch event, and it gives the X and the Y values, and it also gives the percentage. So it was 81%. Am I reading that right? 51%, sorry, I have my wrong glasses on. Yeah, 51% in the X direction and 66% in the Y direction. We use percentages because, of course, these screens are usually different numbers of pixels. So one of them might be 2,440 pixels from top to bottom, and the other one might just be 1280. So what we actually do is when we receive a touch event, we convert it into a percentage across the screen, and then we send that as a percentage across to the server, where it is then coded back into pixels using the server's screen. Otherwise, you would get mistouches where the touches would appear in a different place than you were expecting. So anyway, you've seen these X's and Y's and percentages, mostly useful, of course, just for development. But here we go. I can show you what some of these buttons do. So first of all, let's click Home. And did you see that? The server screen went to the home, and on the client we can see now it redrawing the home. The network is actually very busy at the moment because it's doing a number of updates and backups. So we normally get a faster screen refresh than that. And let's look at multitask. So I'm going to press the square button in the middle. And there we are. That's what they're calling multitask. It gives you a list. It gives you a list of all of the apps that are running, so that you can choose which one you want to go to. And we can go back to our server by touching it. So there, our touch was accurate, went to this, it selected the correct thing. And then the last thing that we might want to do is to disconnect. I won't actually disconnect now. Instead, I two-finger unselected the bar at the bottom. So that's the code running. Let's now go and see how it does it. So, as you can see here, we've got all of our Series 2 apps. We'll start in the client, so AIS 202 Remote Access Client, and we're going down to Main, Java, COM Scarlet Line, and then the name of the actual app. And you'll see there are two Java classes here. One, full screen activity, is the GUI. I'm going to switch back to my coding glasses now. And the other one is the service that runs in the background. You may remember these from when we were looking at the generated code documentation a few minutes ago. If you look in, first of all, we're looking in full screen activity, as I said, the UI, and when it's created, on create, it sets up a touch listener. Now this may not be surprising. It's a pretty standard GUI. On the touch listener, we put our on-touch function, and every time somebody touches with one or more fingers the screen, what we do is capture the location on screen and then call pointer called with the X and Y coordinates and the width and height of the screen. I think you can see now how we're getting the proportion across the screen. So if I touched in the middle of the screen, then X might be 640 of the width 1280. Okay, so X will be about half of get width, and then pointer called can use that to turn it into a value, a fraction from 0 to 1 in X and Y direction. And let's look at that now. Here it is, and you can see it being passed the left, the width, the top. So here's where we get the two-finger toggle, and we use that in order to bring up our meta controls, if you remember a few minutes ago. If it isn't a two-finger touch, then we want to send it through. Now we send through downs, moves, and ups. Move is drag. And what we do is we get the coordinates. We do a conversion here. The reason we do it this way is this is the only way that you can guarantee on any Android device, regardless of operating system or physical device, you always get the percentage across the screen accurately. So we need to get the raw, the unprocessed X, because in different situations it's interpreted differently. That's no good to us. So the X and Y events, and then we work out in the view what percentage. We make sure that it's valid. So if it's outside of the bound 0 and 1, then we report it. This obviously shouldn't happen in normal circumstances, and then we send it. So we call on the service which is running in the background and will keep going whatever happens. We ask the service to do client send pointer, and you'll notice that we're just passing those percentages 0 to 1. So we're now abstract from the device. And let's go through now to remote control client service. Here's client send pointer. Now here you see, you may remember I was talking about the code documentation. These are the comments that it's generated from. On both Macintosh and, on iOS and Android, we use the same, what has become universal way of documenting. Anytime it's /*, it's considered to be documentation. And this is how we format it so that the documentation picks it up and parses it correctly. So we do client send pointer. Here's a bit more explanation about what we expect in these values. And then we do a client send pointer event, which is where it goes down to the C code, C++ code. Because client send pointer event is a native call. So let's go over now to the C++. This is our VNC client. And here's the code. So you'll recognize these flags now. It's bits 0 to 7 are the buttons. You can have up to 8 buttons in VNC. These are the positions. Now, you'll notice that the VNC client block, when we established the connection to the VNC server, one of the things it told us was the size of its screen, or the size of the screen according to it. On the server, we have the AIS VNC server code, and what that does is it scales down the server screen in order to enable this to be real-time responsive. We don't want to be we don't want to be shipping huge screens over the network. So what we do is we scale down the server screen to a quarter of its area, and then we maintain the fiction that the screen is really that size, and then we just scale back when we're given the information. That gives us a real-time performance without any noticeable degradation, because as you can see, it looks exactly like it does in real life. You'd need quite a large magnifying glass to be able to see any difference. So here's where we scale it to actual pixels, and then we send the pointer event through. So let's have a look at that. And I think this is where we say goodbye to it and have a look, start looking at the server code. Yes. So that's then when it goes through the standard VNC lib. Now, this will then be received on the server. So let's go and look at the server. It's obviously received in the C++ code because we can't run a VNC server in Java. It simply wouldn't be responsive enough. Here's our AIS VNC server and the C++ code. So this will receive the touch event. The touch event has been coded into a block and sent over the network to the server. through a secure socket set up by SSH, by the way. So when we receive a pointer event, here it is, we receive a pointer event. Now there's the button mask, tells us which buttons. Obviously with touches we're just using button 1. X and Y and the client pointer, and then so we inject that touch event. So this code couldn't be simpler. You'll notice the details there that we put in. And here's where we actually inject the event. So we make sure that we've got the right fraction of the screen using the actual size. And then what we do is we inject the event. So when AIS VNC server starts up, it queries the Android system down at the Linux kernel level. I'm sure you know that Android at its core has a Linux kernel, and so all event handling, touchscreen, if you had a Bluetooth keyboard or mouse or anything else like that, is all handled through the Linux kernel. So what we do is we scan all of the running devices, input or output devices, and we find the one that is most likely to be the touchscreen by looking by its name or the types of things it responds to. There will only be one candidate out of about 14 or so, typically 14 or so event handling devices on a typical Android device. We are very flexible when it comes to how that's set up, because we don't know what type of touchscreen was used, whether, for example, it is pressure sensitive, whether it's capable of multi-touch. There's various other things. So what we do is when we start up, we find out all these details, and then we make sure that we're going to generate correct events for it. So here you can see if it's got multi-touch tracking, button touch, if it asks for multi-touch positioning. So there's all these different things that we handle. Whether it needs pressure. We put all of this information together, and then we send the events that it's expecting, so that from the Android device point of view, it doesn't know that somebody's not actually touching the screen. There's no way that it can distinguish, because we are emulating a screen touch. We then inject those, so there's all that detail in the event, and then we write it to the touch device. Down in the Linux kernel, the devices are file handlers, and that is then received by the device. There isn't any higher level code in this in Java, because if we tried to handle this in Java, we would only be able to intercept touches on our app. But I don't know if you remember earlier on, we were able to send touches to the system completely. We can completely control the server device from our client, not just our own app. Let me just demonstrate that now. So to touch, home, and I can select, let's select the AIS information app. So I'm going to click that now. There it goes. I did that on the client, and I can actually drive this. You can see it scrolling up there. So because we're at the kernel level, we can completely remote control the device. And then if we want to get back to our own app, we can use multitasking. So I click the square button, and then I can choose our server. And I'm doing all this from the client. I haven't touched the server at all here. And then at the end, we can disconnect. So I'm now going to select the icon on the very right, which will disconnect the client. There we are. remote server disconnected, and it's now ready to be reconnected to. So what we've done there is we've followed a touch event all the way through from when we touch the client screen to when it gets received and acted upon on the server.